Okie dokie. Question 6 from exercise 2C part 2. Straight out your book, here it is, question 6. We're trying to find unknown numbers A and B. They give us some information. So when x equals 3, the function equals 1, or the y equals 1. When x equals 3, the derivative equals negative 1/8. So I've written that down here. And we're ready to start. The first bit of information was when x equals 3, y equals 1. So let's substitute in those values. Right? Let's say, therefore, 1. Right, so my y value is 1, my x value is 3. 1 equals a divided by the square root of 1 plus 3b. Right? I like to see if there's any tidying up I can do. Not too much, but we could write that then a equals the square root of 1 plus 3b. Looks a bit neater. Right, so we've multiplied both sides of the equation by this square root. Okay, so that's about all you can do there. We need to find the derivative. You'll notice I've rewritten the equation here using negative indices. We're about to use the chain rule. Right, so the derivative, so about to find the derivative using the chain rule, and it's easier to do that if you change your square root to a fractional power. So remember in class I was saying the chain rule can be thought of as the outside-inside rule. Right, so let's deal with the outside. This power comes out the front here. We could write minus a on 2. Right, so that's minus a half times a. And then we would need to subtract 1 away from that power. The inside, you leave it alone. Right, so minus a half minus another 1 would be minus 3 halves. Minus 3 on 2. And now we find the derivative of the inside, which is just b. Right? Because derivative of 1 is 0, derivative of bx is b. We can probably squeeze that in. So if we're multiplying everything by b, I could write my b in here. It looks a bit neater. We know that if x equals 3, this derivative has to equal minus 1/8. I could say therefore minus 1/8 equals minus ab on 2, 1 plus 3b to the minus 3 on 2. So I'm just substituting in x. My x value is 3 and my derivative is minus 1/8. I don't like working with negative powers, so I find it a lot easier to view something like this using a surd form. So I'm going to rewrite what I've just done, but instead of leaving it as minus 3 on 2 power, I'm going to write it like this: 1 plus 3b square root 1 plus 3b, because this is all just the same thing, right? So the power here is 1, the power here is a half, 1 plus a half, 3 on 2, so they're the same thing. This can be tidied up as well. If I multiply this whole thing by minus 2, so I can see I've got a negative on both sides, right? We can get rid of that and make these fractions positive. If I times by 2, this 2 here cancels out. This fraction would then change to a quarter. So I could say 1/4 equals AB. 1 plus 3b, square root 1 plus 3b. I could keep going with a bit of simplifying here. Right. I could say 4ab, so multiply both sides by 4, multiply both sides. I don't think I will though. I just have, right? So you might want to keep going, but if we recall that a was the square root of 1 plus 3b, if I then substitute, I'll call this equation 1, equation 2. If I substitute that a into this equation here, the square roots will cancel out nicely. So I think in this instance, we're going to I'll just leave it as a fraction. Sub 1 into 2, because I can see that cancellation is going to come up. So we would have 1/4 equals the square root 1 plus 3b times b on 1 plus 3b times the square root of 1 plus 3b. So this is the cancelling I'm talking about here. Right, so that square root divided by this square root, because they're the same, equals 1. And we'd be left with 1/4 equals b on 1 plus 3b. Right, let's multiply both sides by 4. Let's multiply both sides by 1 plus 3b. We'll get 1 plus 3b equals 4b. Therefore, 1 equals b. Right, so minus 3b from both sides. We can now work out a. All right, running out of room here. So therefore, a equals, this is coming from equation 1, I've labelled it. A equals the square root of 1 plus 3 times 1, because I've found what b was. 1 plus 3 times 1 is 4. A equals the square root of 4. A equals 2. Right. All right, so we found A, we found B. B was 1, A is 2. I would just reiterate, I won't do it here because I'm sure the video is already long enough, but what I could do is go back to the original function, put these numbers in. So we said A was 2 and B was 1. Right, so 1x or just x. I could then do a check and think, well, if I make my x 3, do I really get the answer of 1? Right. And you do, because you'd end up with 2 divided 2. So, when x equals 3, y equals 2 on the square root of 4, which is 2 on 2, which equals 1. And that's what we know it should equal. So therefore, we do have the correct answer. A was 2, B was 1. And it didn't take very long to check that, actually. Okay.